Welcome back to the third part of the Resident Evil puzzle tutorial series, this time in C++. And once again, we are back in Visual Studio. Last part we kind of left off a bit half done because of it taking a bit longer than I expected, but we're going to get right back into it and immediately get into the actual widget. We're going to have two classes we're going to work on, the widget and the character, because the character needs to interact and let us know that we are overlapping to make the widget actually appear. Let's get into it. We'll start with the widget so we can actually, because it's a bit particular, it's a bit different from other classes with how it handles its components, so to speak. So let's get into that. In the last part, I explained how for declaring works. So we're going to start with that. We're going to make sure all our classes are ready to go before we even start making anything. So we're going to put a little bit of space here, and this is going to be where we forward declare. So we're going to say class U vertical box. We're going to look for a class U overlay. And we're going to look for a class ARE character, like this. So these are the three classes we're going to need, but we don't want to have a include here because it's not necessary, because they're going to be pointers. So we'll just leave them like that. Next, we're going to have a protected section. And in this protected section, we're going to add our vertical box, we're going to add our overlay, and that's what these two are for here. So we can use them for that, so we can actually design our widget and still use the functionality within the actual C++ class and not just in the blueprint version. So the way you do that with a component, or more like a widget component, is a little bit different from how you do it with, let's say, a component in the character. So to start, we want to get uProperty as usual, because we want this to be exposed to the blueprint system or just to the editor itself. We're going to say edit anywhere this time. And we're then going to add blueprint read and write, because we want to actually be able to change this variable potentially at runtime, or at the very least read it. I think write is necessary because we are going to change like its visibility beyond just saying get. So in that case, we need to have it be write as well. Then we're going to type in meta equal parentheses bind widget. And this is crucial. Without this, all of this won't work, or most of the logic concerning our vertical box here is not going to work. So now we're going to type u vertical box, which is the class, put it as a pointer because it's a reference, and we're just going to call this vertical box. Now, the reason this is a bit different from a normal, let's say, if we go back to our, our puzzle piece here. And the reason this is a bit different from, let's say, our piece mesh here is because we don't have this bind widget section. And obviously this isn't a widget, so you wouldn't need that. But the reason we need it for the widget is because by default, if we were just to make this, it would just be a vertical box. And we're in C++ at least, sorry, when we use we don't have a constructor, or we don't use the constructor like we use the constructor in our character here, not our character, in our puzzle piece. So because of that, we can't actually initialize our static mesh component the same way. So and the reason for that is because we need to visually drag our stuff in the widget and place it as we want, and it's not always in the same location, same parentage. So it's a bit more complex, and this bind widget is designed for that. So what this means is, as long as this, so let's say if we were to go into our widget now and let's say add a vertical box, this whole class now would be an invalid and wouldn't be able to compile unless we have a vertical box type called vertical box. It will give us an error, and I'll show you once we get to it, but that's what this bind widget is for. It's to say that any uVertical box that is created called vertical box will be associated with this variable in C++. That's what it's for. And so we're going to do the same thing. So we actually just copy this, to be fair. And we're just going to replace vertical box by our overlay, like this. And we'll call this overlay keybind. That. Now, this does it for these two, as far as the visuals are concerned. Now let's get to the different functions and other variables that we might need. So first, we're going to do some inherited stuff. So we're going to say virtual, and we're going to say NativeConstruct, and it should appear like this. Close, open and close parentheses, and just say override. Now, NativeConstruct is essentially the construct you're familiar with in blueprints, and this will also be called before the actual construct itself inside of blueprints. Then we're going to add virtual native tick, as we need to move the widget in real time. We could put this, to be fair, on a timer, but we're just going to do it on the tick because it's easier to set up. And this actually needs a bit more than just the usual delta time. It needs a const f geometry node. Yep. And my geometry. Like this. I think I have an extra letter there. Comma. And then we have our float in delta time. And call override here. And you want to make sure this is spelled exactly the same. If you want to make sure this is right, just go to the parent class user widget here and search for native tick. And it should be able to be found if you just go and control F for it. There we go. So here we have our virtual void native tick. So we could just copy this over like this as well. That also works like this. And we'll just paste it here to be 100% sure. And then we will add our override. There we go. So just to be sure we have the name correct, we can copy it from there. Next, we're going to have two functions. We're going to have they're both going to be void. First one is going to be void receive underscore new closest. And it's going to have a parameter of type actor. So type AA or A actor pointer. I will call this new closest. And semicolon to finish. And another one after called void receive end overlap. And this is also going to be an A actor pointer called last overlap. Now, the reason I'm putting receive underscore is because I like to do that as a naming convention of sorts for when actually I've just realized I forgot the void here for native construct. Otherwise this won't work. The reason I just put receive is just so that I know that these functions are specifically used to be bound to a delegate, which is an event dispatcher in Blueprint, so that I always know that these functions are for specifically that. They're used to be bound to another function. Now, this receive doesn't actually do anything. It doesn't change the function. It doesn't mean it has to be used for delegates. It can be used alone. That's fine as well. But it's just a way to be clear for me, at least. Next, we're going to add an AActor variable. I'll just call it an actor variable. And we'll call this interactor target. We're going to initialize it by setting it to a null pointer. We're going to have another one, which is our character, which is going to be ARE underscore character pointer. And we'll call this character, or you know what, as character reference, we'll call it, which is also going to be a null pointer by default because we don't know what it is. Then we're actually going to make a widget or an animation reference, so to speak. Now, I'm not exactly 100% sure about this, so we might try two different things. So we're going to make a UWidget animation pointer, and we're going to call this keybind animation, and we're going to put it as a null pointer as well. So what this is for is so that we can have an animation in our widgets, which in our case is going to be the fade in and fade out of the actual keybind itself as we get close to the actual interaction object. And so we need a way to store that, so that we don't always constantly go and get it every tick. So we just do a store because it's never going to change. Now I'm going to make this a U property, and we'll say blueprint. Actually, I think we'll try edit defaults only. Now in my project, I just left this as a C++ variable only, because we're going to use another method to get it as well. Now, I'm not sure if this actually works, which is why I'm just going to try it, and we will see. The other method to get this, because obviously in C++ we don't have the animation, and we have no way to get the animation, but there is a little trick you can do, which is what we're going to do right here, and that is we're going to use a blueprint implementable event. And so what these are is they're functions essentially that don't have a definition inside of C++, and we set their definition inside of the blueprint class. And so that means whenever this function that we're going to make gets called in C++, it refers to the blueprint that is calling it and checks its definition. So you'll see more clearly once we get to it. So right here, let's make a new U function. We'll call it blueprint implementable event. So this is a mouthful. And I'm pretty sure I spelled it correctly on the first go. Yeah, absolutely fine. Category, we'll just put getter. not 3Ts. Now, I'm going a bit fast there for typing that, but if you type it a bit slower, normally the IntelliSense should be able to catch up and autofill it for you. So I just go quickly because I know what I'm writing, but in your case, take it a bit slower maybe, and it will appear. So for this, we want to get essentially this. So we're going to put the pointer as a return. We're going to say get show, or actually I like to do BIE for blueprint implementable event, and we'll say get show keybind animation. And this is a const. We've already done const before, but just a reminder, const just means that anything that happens within this function doesn't affect anything outside, which is perfect for a getter because it just gets the variable and returns it. Now, right now, if we compile this, this function would look a bit strange because it would appear as BIE get show keybind animation. So we can actually change that in blueprints by adding some details to our U function here. So add a comma after getter and type meta equal and parentheses. And inside the meta, instead of putting bind widget like we did up here, we're going to say display name equals to quotes. And we'll just say get show keybind animation. And you can do this meta display name. You can do it for any function and any property. If you add meta parentheses or equal parentheses display name, you can change the name of essentially anything. And it does not affect the name here. It's only for blueprint purposes. So there we go. So now we're just going to set up these four functions, and then we'll go and show how this works. And we'll also test our edit defaults only here. So we're just going to go and make all these definitions. So create, native tick create as well. And our fourth one here. Now, right here, you're going to get an error. It's going to say that something's wrong, and it's going to say we want a definition, but we do not give a definition. If it is blueprint implementable event, we do not give a definition. You just leave it here. Even if there's an error, it will compile. It won't be a problem. So let's go and make these definitions. So the first thing we need to do before we can do anything at all is we need some includes. And the first three we're going to need is obviously these three, because now we actually need to work with them. So we're going to do that. For the UI, I'm just going to separate them a bit. We're going to need hashtag include components / overlay, dot header. Most of, I believe, the widget stuff, the basic widget stuff that you're used to is in the components. So for the same vertical box, we're going to say include components / vertical box dot h. Same thing there. Then we're going to need something for the animation. So we're going to say hashtag include animation / widgets animation dot h. There we go. And last but not least, we actually need a reference for the canvas panel so we can actually move our vertical box around. So we're going to say hashtag include components again, like this, canvas panel slot.h. And just to finish off, we need a reference to our interface, and our character. So we're going to say hashtag include tutorial / re character.h. And also as I mentioned, we need the interface, and so that's going to be tutorial as well / and now it's going to appear, so we can just look for it, our interact interface. There we go. So I think we're still missing one here, but I'm not actually sure if it's necessary. So if it is, we will add it. But for now, let's go with this. So super, as usual, native construct, because if we don't do that, we don't call the parent function, and the parent function does all the logic we actually need. So we can't exactly skip it. We're then going to save our character, which I don't think we called character. We called it as character reference, is equal to cast our ARE character. And what we're going to cast is we're going to cast the get owning player pawn, because if we spawn a widget, it is always on a character because it's on the player's screen. So that means it always has an associated player state, a player pawn, and a player controller. So we're just going to use that. We're going to say get owning player pawn. parentheses because it's a function, and there we go. And the semicolon at the end, otherwise it will say there's an error. And now we can check if our character here is not valid. We return not character but as character reference. So if this fails, essentially, meaning for some reason it's not the right character class or our character doesn't exist for whatever reason, shouldn't happen but it's possible, then we do nothing. Now if we do succeed, we're going to get our I'll paste it as character reference, and we're going to say on start. Yeah, okay, so I thought so. So the next part for this, we actually need our character to have some stuff done. So I'm just for now going to put it as a comment, and we'll get to it in a second. The next thing we need to do, just very quickly, is we're going to say our keybind anim is equal to our get show, our BIE get show keybind animation. As you can see, it gets to call this just fine. I don't think I called it keybind anim, did I? No, I called it keybind animation. There we go. So this should be just fine. That does it for our begin play. We'll just have to come back to this in a bit. Native tick we'll do last. First, we're going to do this. So for receive closest, we're going to say our interact target is equal to our new closest. And for those who are familiar with our blueprint version, essentially what we're going to do is we're just going to see whatever object is closer is going to be passed into our new closest here, and we're going to set it. Now, I'm not sure why there's an error here. I think it's just a bit slow. Unless I didn't call it I called it interactive target. So rename that. And all we're going to do is we're just going to make sure that set visibility of this widget is properly visible. So we're going to say eSlate's visibility is self-hit test invisible. So this just means that it can be clicked, or the children can be clicked on, but not the actual class, or not this widget itself, which is what we want. Anyway, we're not going to be clicking on it, so even if it was just visible or not testable at all, it would be fine. Now, on the other hand, if we receive end overlap, that means there is nothing left. So we're just going to say it is hidden. So set visibility to be hidden instead. And we'll make sure we reset our interactor here. So interactor targets needs to go back to being a null pointer, so that we know there is nothing to look at. Additionally, if we have nothing to overlap as well, we want to make sure our overlay keybind, which is just essentially the thing that we're going to display as we move in further and closer to the object, we'll set it to 0, because if it is not within our detection range, then that overlay shouldn't be visible at all anyway. So we're going to say overlay keybind set render opacity to 0, like this. And make sure you set render opacity, because that's what we're going to be changing in our actual animation. So that's why we use that's why we use this here. So that does it for our new closest. It does it for our receive end overlap as well. No errors. Now we just have to do the tick, and the tick is the most complicated part here. So we have a lot to do here. We're going to start by making our parent call. So native tick, parentheses, we put my geometry, and we put in delta time. There we go. This is what we want. Now we get to the next part. So if our character, or our as character reference, is invalid, then we want to say return like this. Because if the character is invalid, we can't do half of the logic here, so we're just not going to do it. Now, if our interact target or interactor target is not valid, we're going to cancel the visibility. We're going to reverse essentially all we're going to do after, but this is just a lot simpler, so we'll do this first. So if our interactor target is invalid, then that means that we have nothing to see, nothing to show. We don't want to see the widget, essentially. It means we have gone to this. Now, the problem is we don't want this to happen and just instantly vanish, because that wouldn't look proper. It wouldn't look clean. So we want to do it a bit differently. We're going to make sure we reverse our animation so that it happens correctly. Okay, no, I don't actually think this is necessary. Now that I'm checking, I don't think we need this. So I'm actually going to delete that for now. And I actually realized now why we need the other last include. So right in here, we're going to go hashtag include. We're going to add blueprint / widget layout library .h. And this is just so we have the function that allows us to move the widget or the icon on the widget relative to the world space. That's what it's for. So if our, sorry, actually we do need this for a second. If our interact target or interactor targets is not valid, we're just going to return as well. We won't do anything. That's not how you write return. There we go. Now, on the other hand, is where we need to do all the other more important stuff. So we're going to start off by saying if a uCanvas panel slot pointer, canvas, or we'll call this canvas slot. And what we're doing here is just checking if our vertical box is indeed in a canvas panel. Otherwise, none of this will work. So we're going to say if it is by checking by cast uCanvas panel slot. Is our vertical box in it? And now we can't just say vertical box here because that won't work, because vertical box itself isn't in the canvas panel. What we're actually looking for is the slot vertical box. So we want to look for slot here, and this will tell us if it works. So sorry, very quickly, if you're wondering what this essentially does, it's the same as saying slot as canvas panel, for example, in Blueprints. That's what this is for. And so if it is, we're going to use a function called uWidget layout library, and we're going to use double colon because it is a static function. So we'll call project world location to widget with distance. So like this. We'll put a semicolon at the end, and now we'll fill out the information. So we want to make sure we have a player character here, player controller, and we can say get owning player, but we can't get owning player controller. So to get that, we want to get our owning player. Actually, owning. Yeah, no, this works just fine. We can just do get owning player. Sorry, this get owning player is the equivalent of get player controller. So if we look here, the type it returns is a player controller. So put a comma. Then we're going to look for where we want to actually interact from. And so for that, we're going to get our interact target. And with the interact target, we want to say, get the interaction location. And the way we do that is we need to know if it can cast to our interface. So the way we do that is actually, instead of by how in Blueprints you would say does implement interface, here we can just say cast to our IRE_interact interface, parentheses to know what we're talking about, and interactor target. And so here it's still saying an error because what it's looking for is a vector. And so what we get is we get our interaction location. Close the parentheses, and now we have a vector. Finally, we need something called the screen location, which is where it's actually going to be set. Now, the problem is this isn't an input, it's an output. So in the previous part, I believe we talked about how those worked, and now we're actually going to apply that logic and do it here. For a location, we need a variable before. So right before here, we're going to say f vector screen location. And we don't need to define it, we just need to say that it exists. Then we're going to go and copy paste it and place it here. And the last thing we just need is just a false, that is a false here, just to say that it is not relative or not player viewport relative. And so with this, we now have a new location that is going to be set to our screen location. So all we have to do now is just say to apply. So we're going to say canvas slot. So once again, this is like if we got our vertical box and said slot as canvas panel, and we're going to say set its position. So set position. And right now, as you probably noticed, this is a f vector, meaning it has x, y, and z, but we only need x and y because it's a position on the screen. But this does take in an f vector, so we do have to put it as an f vector here. but we're only going to use our X and Y. So to do that, we will say screen location dot X and screen location dot Y. And I believe, sorry, no, that doesn't work. And the reason that doesn't work is because this is looking for a F vector, not two floats. So to get that, we'll just convert these by saying F vector, 2D. And I actually believe we can just say screen location, and that will work if I'm not incorrect. Yeah, so what it's doing right now is it's noticing that we have an F vector inside. So this is just essentially initializing a vector 2D with a vector 3D. And it's constructing it by saying it's only copying the X and Y from the F vector, which is exactly what we want. We just want the X and Y. So this will work just fine. Now, the last thing we need is we need to actually set up our animation. Because right now this is perfect for making it follow. It will follow the cube or whatever we have in the world perfectly with just this. That's all it needs. But now we need to do a bit more complicated stuff just to say that we want to show the keybind at this moment when we get close enough and hide it when we get too far. So to do that, we just need some very annoying logic. It's not necessarily complicated, just a bit annoying to get through. So we will start by saying F vector dist, because we need to get the distance between 2 points. And you know what, while we're at it, because right here what we're going to do is we're going to do the same thing here again. We're just going to save this separately, so we don't have to do it twice. So we'll just say F vector interactor location is equal to this. There we go. Now, do note there is a chance this can fail, because if this is invalid, as in it's not a, as in our interactive target cannot use this interface, then this will cause an error. This will crash your project 100%. The reason we're doing this here without any checks is because the only way this interactive target gets added in our new closest is if we've already checked that it is a valid interface user. So that's why we're not doing the check here, because we know it's going to work. So interactor location, plug it in here, and just remove this extra stuff, and it should work just fine. Now for distance, we're going to do the same thing. We're going to paste that in. I'm going to say as character reference, get act location. There we go. I think that's an extra parentheses. Yes. So right now this gives us the distance, but we still need to know what our max range is. And we don't have that because it's in the player character. And so we'll need to set that up in a second, or actually we'll set that up now, because otherwise we're gonna take forever. We're just gonna have to go back and forth a lot, and let's just do this now. So for now, just go to our player character, set a public variable of type float, and it is called interaction range, and we'll say something like 500 to start. Now we'll make this U property later, but for now we just want to copy this, go back to our widgets, and we're going to say if this is inferior to our as character reference, and then put an arrow and paste our interaction range. Now it's going to take a second because we just made it very quickly, but essentially what this is saying is if our distance between our interaction location and our character location is below the interaction range, that means that we want to start showing the interaction range if necessary, or the keybind if it's necessary. So this is just going to be a little error for now while it figures this out. And what we're going to say is if our animation is playing, or not playing, sorry, so is animation playing, and the one we're looking for is our keybind animation. If this is not playing and our overlay keybind render opacity, so get render opacity here, is inferior to 1. So what this means is if it is not playing and it is still not 100% visible, we want to play the animation. Now, if it is 100% visible, then we don't want to play the animation, or if it's already becoming visible, we don't want to play it again, it is already running. So we'll say play animation, and we're going to look for keybind animation here, and we will set it to get current animation time, and we'll also plug in keybind animation. And what this does is just play the animation. We use this to say, well, if for instance if we're moving in and out of the range, it plays from where it was before. So if it was like halfway through, it won't go back to the end or restart at the beginning. It'll go from where it is currently instead of like jittering back and forth from beginning to end. So that's what we have to do here. Now we have to add the opposite. So else, if we are not in range. And this is still showing an error for some reason. This is a float. Oh, sorry. I forgot the parentheses. It didn't know what the distance was. So now that should work. And now there's a missing parentheses here. And that should have fixed it. Because now this large parentheses is for... Sorry, no, I have way too many. Yeah, that works. Sorry, that was my bad. Add a few extra parentheses unnecessary. Okay, now here. The opposite, meaning we want to hide the keybind. So we're just going to say if the overlay keybind get render opacity is inferior or equal to 0, then we return. Because it's already invisible, we don't need to do anything. Next, if is animation playing again, we're going to say is keybind animation playing. We're going to check if it is playing. If it is playing, that means that it is either going backwards or it is going forwards. Now, if it is going forwards, we need to make sure that it stops. But first, what we're going to say is if it is playing backwards. So to check that, we'll say is animation playing forward here. And we're going to use our keybind animation as well. We will return. Now, I put an exclamation point because it's the opposite that we want. If it is playing forwards, we want to stop it. But if it is playing backwards, so the exclamation point, inverting it, then that's fine. That's doing already what we need it to do. So we don't want to touch it. Now, on the other case, meaning this fails, meaning it's going forward, we want to make sure we say stop animation. And we will say keybind animation here. That's not how you write keybind animation. Now, before we do that though, we need to make sure we save the current time, because if we stop the animation, it will reset itself to 0, but we don't want that. We want it to replay immediately in reverse from where it was at. So we're going to say float current time is equal to get animation current time. And the animation, once again, keybind animation, we're not changing anything there. And that will save it before we actually stop it. So once it has been stopped, we can now replay it. So we're going to say play animation, and we're going to use the same thing as this, but it's a little bit different this time, because even though we just had 2 parameters here, this function actually has a bit more. If you look here, you can see it has 1, 2, 3, 4, 5, 6, 7 different parameters. And the reason we don't have to actually fill those in is because some of them are already set. If you look, it says float start time is always equal to 0 if nothing else is input. So we didn't put anything else, so it doesn't need anything else. But we're going to add some more here so that we can actually reverse it. So we're going to say keybind animation is the animation we're going to play. The time is our current time that we just saved. We're going to put 1 for how many numbers of loops. We only want to do it once. It's not a looping animation. And then we need to change the play mode. So the play mode is going to be EUMG sequence play mode, and we're going to type double colon, and we're going to say it's going in reverse this time. Add a semicolon at the end, and that will play our animation in reverse from the current time, 1 time only, in reverse. Now, on the other hand, if the animation is not playing, we're just going to reverse it. We're just going to say else play animation reverse, and we'll say keybind animation. And that does it for our interact. So let's go and compile this. Let's just see what is happening here. I think this is an error. There we go. Let's compile. So Control F5, wait for it to load, and I'll be back with you once it's ready. So once we've got our editor loaded now, and we go to our UMG interact, you'll notice that you have an error here, a compile saying there was an error during compilation, see the logs. Now, as I mentioned, the reason this is occurring is because of our setting here for bind widget. And right now, if we go back and try and compile, let's say we compile here, it's going to give us an error saying that it requires the binding widget vertical box, and it can't find it. So that's because this is empty right now. So let's go and set all this up. Now we'll start with a canvas panel because we need to move stuff around the screen. So a canvas panel. Then we're going to look for a vertical box, which is going to contain our actual stuff that moves around. So here's fine. We want to make sure our vertical box is centered. So go for the not the anchor, sorry, the alignment, say 0.5, 0.5, so that it looks like this. Inside of it, we're going to add an overlay like this. And in the overlay, we're going to have an image and we're going to have some text. So image and a text like this. And then we're going to have another image below for the actual arrow. So for the arrow, just go to our brush. We're going to say, I believe we're looking for inputs, I believe it's called, arrow 2. And make sure this is centered and fits to the bottom. Sorry, this should be to the vertical box, not the overlay. This is what it should look like. Make sure it's fill. And our vertical box, I believe, needs to be size to content or not. Sorry, no, it needs to be 60 by 60 is what it needs to be. 60 by 90, sorry. Not 900, 90. So this is what it should look like here. Still the error here. We're going to make sure, to avoid this error, we just need to go to vertical box here, rename it to vertical box exactly, because there's a space bar there. Now if we compile, we only have the overlay now. So same thing here, rename the overlay to overlay keybind. There we go. Compile and save. And that will do it, or at least that'll do it for the errors. The errors are now gone. We can play without any issue. The next thing is the other image. So we're going to go for the other image here. We're going to make sure this is centered as well and aligned to the bottom. We'll replace it with our input key 2. Yeah, this is fine. It looks a bit weird for a second because we still need to change this, because this needs to be set to fill as well. There we go. So now this looks a bit better. For the text, we're going to change it obviously from white to black so we can actually read on it. And so just drag this here, and we're just going to change the text to F. We're going to make sure it is centered here, and I think that about does it. We want to make sure this here is a bit smaller, so image size, instead of 512 by 512, we'll just put it to 30 by 30. And I think we do the same thing for this image as well. We change it to 50 by 50. So 50 by 50, and now it actually fits within. And I think for this, we're going to give it a little bit of padding on the top by opening this up and saying top, we'll say 5. I think that's good. That works fine. Now, the next thing we need to do is we need to do our animation. Now, for the animation, the first thing we want to do is we want to make sure our overlay is hidden by default. So we're going to select our overlay. We're going to make sure its render opacity is 0. So drag this all the way down, and it should be hidden here. Now, next, I want to make sure if our little test works here. So as you can see, we have a keybind animation, and we can't put anything in here. Now, if we go and create an animation, I don't know if it will appear there. So animation, we'll say keybind show. And let's go and check here. It doesn't appear. Even if we compile, let's double check. No, so this doesn't work. So that means this method doesn't work. We have to use our blueprint implementable event. So go to graph, search in our override for our get show keybind animation. And as you can see, we don't have the BIE before, even though if we look at the description a little bit on the right to it, we can see it says BIE show keybind right there. So click on it, and all we have to do is just get our keybind show and plug it in here. And that will all be handled from now on. The last thing to do is in our animation graph, we're just going to make our show animation. So all we have to do, and this is up to you, I'm going to go to here at the start. We're going to add our overlay keybind. We're going to get its render opacity by clicking on the plus here and adding the render opacity track. Plus here to make sure there's a key at the beginning. If there isn't, there should be by default. And then here at 20 or 0.2, we press 1. And so now it will, if we play, appear like this. So it's rather quick. So in most cases, you'll never end up in the middle, but if we do, it can handle it. Okay, so that does it for animation. That does it for all the interact now is done. We just need to, in the next part, go back to our widget interact here and finish this bit off once we've done our character. And I apologize for not doing this all in one go, but because of how large the work to do in the next part is, or how much there is to do on the character, it would take at least another 30 to 40 minutes, and I don't want to do a 1 hour and a half video because I feel like that will be more annoying than anything else. So I apologize for that. I hope you still enjoyed and still learned something, and I will be seeing you in the next part to finally finish off the interaction part. So thank you for watching. Thank you to everybody on Patreon who's been supporting me. I'll see you in the next part. Goodbye.